example here of coupled rotational translational motion. In this case, I have a bicycle that's moving at 9 meters per second. The radius of both of the wheels is 0.3 meters. And the question is, what is the angular velocity of the bicycle wheels, or either of the wheels? And this is an interesting problem, but the coupling happens here at the ground. And what happens at this point at the ground is, in order for these things to be coupled together, the velocity here has to equal 0. So that we're not sliding or slipping across the ground, we're just rolling without slipping. So there's two different ways we could think about solving this problem. One of them is what we would call relative motion, where we would think about this wheel, for example, the point velocity where it's 0, as being a combination of the total translation of the wheel moving with the bicycle and the rotational component. And at that point would have to equal 0, the combination of those two things. I'm going to do it a slightly simpler way here, which is to recognize that if the velocity here is 0, because it's coupled, then we consider the entire wheel as rotating not about the center, but instead as about the point on the ground. And then we can use our equation V is equal to omega r at the point where we know the velocity of the wheel, and that's at the middle. If the whole bike is moving at 9 meters per second, then this spot at the middle has to be moving at 9 meters per second. And if that's true, then we just need to know the radius between the 0 velocity and the spot where it's moving, and that's going to be the same radius, 0.3 meters. And we can use that to figure out the omega. So plugging it into my equation, we know 9 meters per second there at the center of the wheel is equal to our unknown angular velocity omega times the radius between this point where we know 0 velocity and this point where we know 9 meters per second is 0.3 meters. And so what that's going to give us is an angular velocity of, I'm going to do this in my head, 30 radians per second. So our final angular velocity should be 30 radians per second.